Hello learners, I am Parikshit Saikia and I teach live on the Unacademy platform. I have nearly 9 years of teaching experience, and in today's session, I'm going to take up a very interesting LRDI caselet. The LRDI caselet is very similar to the Sudoku puzzles which you see in your morning newspapers. So let's get started with this amazing caselet. Let's read the caselet together. 16 consecutive natural numbers are filled in a 4 into 4 matrix. 4 numbers are already given. Numbers are filled in such a way that the sum of each row, each column, and each diagonal are equal. Okay, it is also known that d plus e plus I is equal to 66. And then they have given you a few questions, right? How many numbers are numerically greater than c, find value of k, and so on. So basically what you need to do, you need to fill this 4 into 4 into 4 matrix such that the sum of numbers in each row, each column, and each diagonal are equal. That's what you are going to target. So please pause this video, try to solve this question first by yourself, and then look at the magical solution that I will provide you. Okay, I believe that you have tried it. So first, let's understand how to arrange numbers in a matrix, right? So let's talk about the concept first. I will go to the question later, okay? I'll go to the puzzle later, but first, let's talk about the concept. Concept of what? Concept of arranging numbers, okay, such that the sum of every number, sum of the numbers in each row, okay, should be equal to the sum of each sum of the numbers in each column, which in turn should be equal to the sum of numbers in each diagonal. I hope you understand what's a diagonal. What's a diagonal? Diagonal would be these one. This would be the diagonal, right? So these would be the diagonals. These would be the diagonals, right? So these two are the diagonals. So the sum of numbers across each diagonal, each row, and each column should be the same. So if you ever come across such a puzzle, if you know the concept, there is actually a trick which many of you probably are not aware. So first, let's understand this concept. Okay, so let's try to draw a 4 into 4 matrix. Let's first draw a 4 into 4 matrix. Okay, and let's say you need to fill up consecutive numbers. You need to fill up consecutive numbers. Okay, consecutive numbers. So let's start writing it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So step 1, write down the 16 consecutive numbers. It could be 1 to 16, or it could even start from 101 to 116. Any 16 consecutive numbers can start from anywhere, right? That does not matter. I have taken the first 60 natural numbers. Now, you need to rearrange these numbers in such a way that the sum of every row should be equal to the sum of every column, should be equal to the sum of every diagonal. That's what your intention is, right? So let's see how we can do this. So let's try to draw this matrix once again. Okay. Try to draw this matrix once again. Fine. Okay. Now there are certain steps that you need to follow. Okay. To come from here, first matrix, to the second matrix. Step 1. What is step 1? I'm writing down the steps. Step 1, exchange the middle 4 numbers. Exchange the middle items. Can you see? 6 and 11, 7 and 10. Exchange the middle 4 items, the middle 4 numbers. Can you see? So I would say exchange. Exchange what? Mid 4 numbers. Mid 4 numbers. Mid 4 numbers. Fine. So can I say 6 and 11? Please exchange 6 and 11. So in place of 6, you will write 11. In place of 11, you are going to put 6. Next, exchange 7 and 10. So in place of 7, you're going to put 10. And in place of 10, you're going to put 7. So step 1 is done. Right? There are just 3 steps. Step 2. Step 2. What is step 2? Exchange corner elements. Exchange corner numbers. Corner numbers. Corner numbers. Exchange the corner numbers. So what are the corner numbers? So corner numbers are 1 and 16. Can you see 1 and 16? Please exchange it. And 4 and 13, please exchange it. That's it. Exchange the corner numbers. So 1 and 16 exchange, meaning in place of 1, put 16. In place of 16, put 1. Similarly, 4 and 13. In place of 13, put 4. And in place of 4, put 13. Step 2 is also done. Step 3. What is step 3? Step 3, remaining numbers as it is. Remaining numbers as it is. Remaining numbers as it is. Okay. So what are the remaining numbers? Your remaining numbers, if you are observing carefully, are 2, 3. So can you see what are the remaining numbers? So first remaining number is now 2, 3. Write down the remaining numbers as it is. So 2, 3. Then 5 and 9. 5 and 9. So please write them down as it is. Next, 8 and 12. Write them down as it is. Next, 14 and 15. Write them down as it is. And magic is done. You are done. Can you verify if the sum of every row is equal to the sum of every column, which in turn is equal to the sum of every diagonal? Please verify. 16 plus 5. Let's look at the first column. 16 plus 5, 21, plus 9, 30, plus 4, 34. So the sum of first column is 34. Can you see? This is the sum. Second column. Can you verify the second column sum? 2 plus 11, 13, 13 plus 7, 20, 20 plus 14, 34. Step 3 or column 3. 10 plus 3, 13 plus 6, 19 plus 15, 34. Similarly, the fourth column, if you verify, this will also come out to be 34. Verify the rows. First row, 16 plus 2, 18, 18 plus 3, 21, 21 plus 13, 34. Similarly, second row, verify 5 plus 11, 16 plus 10, 26 plus 8, 34. So all of them will again come out to be 34. Yes, this is magic. And trust me, it'll work for all even case, all even matrices. So it's a 4 into 4 matrix, 6 into 6 matrix, 8 into 8 matrix. Every such matrix, this shortcut or this magical trick is going to work. So can you add up diagonally? 16 plus 11, 27, 27 plus 6, 33, 33 plus 1, 34. Diagonal sum is also 34. Diagonal sum is also 34. Can you see? Similarly, look at the other diagonal. 4 plus 7, 11, 11 plus 10, 21, 21 plus 13, 34. So diagonally also it satisfies. So you understand the concept. The concept is it's a 3-step process how to arrange numbers such that the sum of every row is equal to the sum of every column, which in turn is equal to the sum of every diagonal. With this concept now, I will get back to the case list. Okay, let's rub this and go back to the case list. So I hope you remember the 3-step which will work for any even cell, even number of cells in a matrix. So 4 into 4, 6 into 6, 8 into 8, all such matrices, it will work, right? Okay. Now let's go back to our question. In our question, I think you have certain numbers which are given to you. So let's first observe whether it's an even matrix. Absolutely it is. It is a 4 into 4 matrix, right? But look at the numbers. The numbers are not starting from 1. Rather, you see a number 15 and another number you say 30. And obviously you understand that they say 16 consecutive natural numbers. Consecutive. So 15 and 30, 30 minus 15, right? I mean, these 15 to 30, basically, there are 16 natural numbers. Do you see that? 15 to 30 are 16 natural numbers. So I can say the minimum number in my matrix is 15 and the maximum number in my matrix is 30, and these are consecutive numbers. So the 16 consecutive numbers must be from 15 to 30. So let's follow the same process. Let's follow the same process. So first, let's write down the 16 numbers as it is. Let's write down the 16 numbers as it is, right? In consecutive order. Fine? Okay. So let's write down the numbers and then we'll change it. So 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So what is the first thing I did? The first thing I did, I wrote down the 16 consecutive numbers. Now I need to apply the three-step process. Yes, so let's draw the diagram again. Let's draw the diagram again and apply the three-step process. Okay, I will draw the diagram again and apply the three-step process. So first thing first, step one, exchange the middle four numbers. What are the middle four numbers? The middle four numbers are 20 and 25. You got to exchange. So in place of 20, you're going to write 25. In place of 25, you're going to write 20. Next, 21 and 24 exchange. So in place of 21, you're going to put 24. In place of 24, you are going to put 21. Step 1 is done. Step 2, exchange the corner numbers. What are the corner numbers? 15 and 30 are the corner numbers, and 27 and 18 are the corner numbers. So let's exchange them. 15 and 30, please exchange. So in place of 15, write 30. In place of 30, put 15. Similarly, 18 and 27. In place of 27, put 18. In place of 18, put 27. Step 3, write down the remaining numbers as it is. So remaining numbers on the top row, the missing numbers are 16 and 17. Write them down as it is from the first figure. 19 and 23, write them down as it is from the first figure. Then bottom 28 and 29, write them down as it is. And then 22 and 26, write them down as it is. Correct? Now, verification time. Let's verify. Can you add up the first column? 30 plus 19 is 49. 49 plus 23 is 72. 72 plus 18 is 90. Can we verify? 30 plus 9, 49. 49 plus 23, 59, 69, 72. 72 plus 18, 90. Awesome. Second column. 16 plus 25, 41. 41 plus 21, 62. 62 plus 28, 90. Similarly, third column, if you add, the sum is again going to be 90. Fourth column, if you add, the sum is again going to be 90. Let's look at horizontally. 30 plus 16, 46, plus 17, 63, plus 27, 90. Similarly, you add like this, it's going to be 90. For each of the rows, the sum is going to be 90. You don't have to do this, but I'm just showing you in case anyone still has a doubt if the sum is actually same for all the rows and all the columns. What about the diagonals? Can you add them? 30 plus 25, 55. 55 plus 20, 75. 75 plus 15, 90. First diagonal is 90. What about the second diagonal? 18 plus 21 is 39. 39 plus 24 is 63. 63 plus 27 is again 90. So every diagonal, or I would say both diagonals also, sum is 90. Super awesome. Job completed. Now look at the question. The author, I think, made the question a bit more difficult because if you see the numbers that we have and the numbers the author has doesn't match. You see the first number, top left, topmost left is 15, while in our cell it is 30. So you don't have to bother about it. What you need to do is figure 2. If I call the second figure figure 2, you just got to take the second figure and turn it upside down. Turn it upside down such that the bottommost part, right? Can you see the bottommost? The bottommost, this portion goes out here. This portion, the bottom right becomes, so just you have a square, right? You have a square. What do? You take the square, just turn the square such that the 15, which is at the bottom right, goes to the top left. Simple. You just need to turn the square so that the numbers match as given by the author. Numbers match as given by the author. So what am I going to do? I'm going to turn, okay, step 3, and the last step for this question, it's not required, but for this question, it would be required. I'm just going to turn my figure. I'm just going to turn my figure, right? That's what I'm going to do. So turn the figure in such a way such that the bottom right, which is 15, becomes top left. So can you say 15 will go up? So I need to rotate the figure, right? And then 27. Look at that question. Look at the question. I'm writing it from the question. 15, 27. And from the question, can you see from the question figure 18, 30? So just figure out. So just fill it up. 15 to 30 from R 15 to 80. Can you see from the second figure? I'm just going to highlight it. I'm just going to highlight it for your benefit. Let me use a different color altogether. Yes. Okay. 15 to 18. Can you say you just need to put it in that order so that it is as per the diagram given in the question. So 15 next to 15 in our second diagram is 29, then 20. Right? So everything. Similarly, last row. Can you see the last row? What is there? 27. 27 to 30. You need to write it in that order. 27 to 30. Right? So please do it. 27 to 30. So 27 next to 27 is 17 and then 16. And then just next to 15. So take up the numbers. Take up the numbers. Next to 15 is which number cell? This one. 26 to 23. 26 to 23. Right? 26 to 23. Put it in that order. So 26, 20, 21, 23. And the last row will be 22, 24, 25. Will the sums of the rows in the column change? No. Why? You just took the figure and rotated it. You didn't do anything else. So if you rotate a figure, remember you have not changed the individual elements. The figure was just rotated. You just put it upside down. So obviously the sum of every row and the sum of every column still continues to remain the same. Now you are ready to answer the questions. Correct? Okay. Let's look at the questions. Let's look at the first question. How many numbers in the given matrix are numerically greater than those denoted by C? So can you locate C? C is first column, second element. So in our case, C is 26. And we have numbers up till 30. We have numbers up till 30. So how many numbers are greater than 26? 4 numbers. 27, 28, 29, 30. Next, find the value of K. K is last row, second element. Last row, second element, K is 17. Find the value of K. K is 17. Next, find the value of H minus I. H minus I. Third row, second and third element. H minus I. So can you see 24 minus 25 is gonna be minus 1. Minus 1 is your third answer. And find the sum of A and B. A and B is your first row, second and third element. A and B. So 28 plus 29 is gonna be 57. That's gonna be your fourth answer. This is an amazing case then. As I said, it's gonna work for a 4 into 4 matrix. 2 into 2 doesn't arise because it's too easy. You can do it yourself manually. 4 into 4, 6 into 6, 8 into 8, 10 into 10. So every even matrix, right? Even number of cells in the matrix, this method is gonna work. It's called a magical method to balance numbers horizontally, vertically, as well as diagonally. So I hope you enjoyed the video. I hope you liked it. If you liked the video, please give a thumbs up and I'm going to see you in my next session. Thanks, folks, and happy learning.